Hi everyone, I am Roopjyoti Barua, a research scholar from IIT BHU, Varanasi, India. The primary motivation behind this work is to try out the basic transformer-based model for this low-resource Odia-English language pair. The highlight of the talk is the background of neural machine translation, proposed approach on this language pair, then corpus statistics, followed by experimental setup, then results and conclusion. Neural machine translation. In this work, we use the basic transformer architecture from the research work Attention is All You Need, Vaswani et al. 2017. The transformer model is the first transduction model relying entirely on self-attention and handling long-range dependencies to compute representation of inputs. The relationship of two words directly modeled in self-attention, regardless the distance between those words. We can take the benefit over the stacked of encoder-decoder layers that allows parallel computation across timestamps. In this diagram, the set of encoders and equal number of corresponding decoders are there. Considering a input English sentence and corresponding in output of Oriya sentence shown below. Our proposed approach in this work in transformer based architecture, we used byte level byte pair encoding, which is proposed by Wang et al. 2019. Recently, all NMT system, the vocabulary have been built by BPE in order to limiting size. An NMT model built on top of the character based vocabularies, that is either characters or subwords or words. The BPE is used at the level of characters rather than bytes. Being agnostic to language, byte representation of text are advantageous in terms of data compression. To deal with the fact the base vocabulary needs to get all base characters, which can be quite big if it allows for all Unicode characters. In this task, subwords are trained directly from bytes instead of characters. Here, tokenize the text into variable length byte n-grams instead of sequence of character n-grams. In this work, we use PyTorch, an open source machine learning framework. Some of the parameter value from our experimental setup are GRU transform architecture, number of encoder decoder layers are 2, ADEM optimizer, learning rate is 5 into 10 raised to the power minus 4, then batch size is 100 and number of epochs is for our convenience 130. The corpus provided by the task organizer of Odia-English version 2, the number of training sentences are 69,000 and test and validations are nearly 14,000 sentence pairs. After submitting the predicted file, the task organizer provided the scores in terms of BLEU, RIBES, and AMFM, that is adequacy and fluency metrics. These are the scores. In case of Odia to English, our system secured 11.33 BLEU score as compared to baseline 8.93, whereas from English to Odia, the BLEU score is 1.34 as compared to baseline 5.49. Similarly, RIPE scores are we got 0.4625 as compared to baseline 0.34, and uh, English to Odia 0.2885 as compared to baseline 0.3261. These are the results of adequacy and fluency. The half part of is Odia to English compared with organizer, that is the baseline and our score, and right half of the diagram is English to Odia uh, compared with our and organizer, that is baseline. Um our FM score, fluency score in Odia to English is 0.4898, and adequacy score is 0.6377, and English to Odia is fluency score is 4.4001, and adequacy score for English to Odia is 0.5025. Uh, at last conclusion, the BBP, that is byte pair encoding, byte level BP based model better than BP based ones, and we improve our quality with the help of multilingual setting because BBP maximizes vocabulary sharing across many languages and achieve better translation quality. And since BBP based model perform better and more compact than BP based model, however, BBP sequences are slightly longer than BP, which shows down the training and inferences. Neural machine translation. In this work, we use the basic